Problem 16. Use the diagram below to answer the question that follows. This diagram, let's see, it's n by 2n. Maybe they want us to do some type of area or something. They shaded in this triangle, which is about half of it. It's exactly half of the area. Let's see what they want to ask us. The diagram above could best be used to derive a formula for which of the following quantities? Interesting. All right, the sum of the first n consecutive odd integers. Now, does that make any sense? So we have n here, and they say the sum of the first n consecutive odd integers. Let's see. If we look at the shaded area, if we look at the height here, that height here is 1. The height of this next column right here is 3. The height of the next column is 5. Every column is incrementing by 2. So these are odd integers, and there are going to be n of them, right? 1, 2, 3, 4, all the way to n of them. And so if we wanted the sum of them, we would essentially just have to figure out the area of the shaded region. So we could use the diagram for that. So the area of the shaded region is 2n times n divided by 2, which is equal to n squared, which is a neat outcome by itself, that the sum of the first n consecutive odd integers is n squared. So that's going to be our choice, A, that you can actually use the diagram to figure out that formula. The other ones don't make sense. The product of the first n consecutive even integers, I don't see where you get even integers, is 1 and a 3 and a 5. So not anything with even doesn't make sense. And then choice D tells us the product of the first n consecutive odd integers. Well, I don't see how this is helping you visualize what happens when you multiply 1 times 3 times 5 times 7 and so forth. Next problem. Problem 9. Use the diagram below to answer the question that follows. Okay, looks like some type of lattice multiplication. The diagram above demonstrates how the lattice multiplication algorithm is used to multiply, I was right, it's lattice multiplication, multiply 231 by 25 to get the product 5,775. What value does the circled digit represent? So if lattice multiplication looks like something completely foreign to you, you just have to, well, I'll give you a quick primer on it. All you're doing, each of these boxes, you're just multiplying the corresponding digits. So 1 times 2 is 2, 0, 2. 3 times 2 is 0, 6. 2 times 2 is 0, 4. 1 times 5 is 0, 5. 3 times 5 is 15, 1, 5. 2 times 5 is 10. And then you add up the different places. So this is the ones diagonal right here. You had just a 5 there. You get a 5. This is our tens diagonal right here. So it's 20 plus 0 plus 50 is 70. And then this is your hundreds diagonal. 600 plus 100 plus is equal to 700. So I just answered your question. They said, what does the circled digit represent? Well, the circled digit is in this hundreds diagonal, so it represents 100. Now, if that still is kind of unfamiliar and you're like, oh, gee, how was I supposed to know about this hundreds diagonal? You could think about it this way. This 15 right here is the byproduct of multiplying that 3 and that 5. Right? 3 times 5 is 15, and then they circled the 1. But what is this, really? This is really a 30, right? This is 231. So this is really 30 times 5. This is just a regular 5. 30 times 5 is equal to 150. So this 15 is really representing 150. Or this 1 is really representing 100. And that makes sense because it's in that hundreds diagonal. So once again, our answer would be C, 100. Problem 18. Use the samples of a student's work below to answer the question that follows. Which of the following statements best describes the mathematical validity of the algorithm that the student appears to be using? So let's see what the student's doing. 9/16 divided by 3/4. He or she is just dividing the numerators and then dividing the denominators. Now that's not the standard, the traditional way that most of us are taught of doing division of fractions, right? The standard way, if we have a over b divided by c over d, or at least the way I learned to do it, I would say that this is equal to a over b times d over c times the reciprocal of this. And I would have gotten that it's equal to AD over BC. This is the standard. This is the standard algorithm. Now let's see this guy over here. If he takes A over B and he divides it by C over D, what he's getting, he essentially, for the new numerator, he takes a over c. And for the new denominator, he takes b over d. And if you were to simplify this, a over c divided by b over d, this is the same thing as a over c times d over b, which is equal to ad over BC. So even though this looks very bizarre and actually very naive because you're just dividing the numerator and dividing the denominator, it works. This will work for any numbers that you put in there. And so, let's see, A isn't right. It is definitely, if try doing this the way you know it, you'll get the same answers. So A isn't, it's definitely, well, here you go, D. It is valid for all rational numbers, as unintuitive as that might be, because it looks like this kid, he just said, I'll just divide the numerators and divide the denominators, just because multiplying fractions, you kind of do the same thing, but it just happens to work. In fact, this is probably how they should teach it, or maybe, arguably, how they might want to teach it. Problem 19. Use the inequality below to answer the question that follows. Okay, that gives an inequality. Which of the following inequalities describes all possible values of x? So let me write. So they're writing 3 over x is greater than 4 over x. So if we assume, well, x can't be equal to 0 because that would just be undefined. So let's just write that down. X cannot be equal to 0. So to solve this equation, we can multiply both sides by x. So if we have to be very careful, though, because if x is negative and you multiply both sides by it, you'd have to switch this inequality. But let's assume x is greater than 0. If x is greater than 0, then when you multiply both sides of this equation by x, you don't have to switch the inequality, and then you get 3. Let me put in a different color. If you multiply both sides of this equation by x, you get 3 is greater than 4, which is definitely, this is false. This cannot be true. So x cannot be greater than 0. So let's see what happens when x is less than 0. If x is less than 0, then when you multiply both sides of this equation by x, you have to switch the inequality sign. So then you would get 3 is less than 4, which is definitely true, right? What I did is just multiplied both sides of this by x. When you multiply both sides of an inequality by negative, you have to swap this. That's why the greater than became a less than, and these canceled out. So you get 3 is less than 4, which is true. So any x less than 0 will satisfy this equation right here. So then you could try it out as, minus 3/4 is greater than minus 4/4, right? You could try it out with any numbers that you might like.